Hello again, my name is Claudio, and today I'd like to cover some information with you on structures. So, if you look at these photos, these are all examples of structures. Some are man made, and some are made by animals. Before we get into a little bit more information, it's important to know where the word comes from. Uh, Structure comes from the Latin word structura, then in turn comes from the Latin verb struere, which means to build. So a structure is essentially something that has been built. There's different types of structures. One of the more important ones are buildings, which are built either by people or animals. There's machines. So in this case, we have a car. But it can also be a washing machine, a dishwasher, a lawnmower, a snowblower. Those are all machines, and they're essentially structures as well. There's also natural objects that are in the form of a structure. So it could be an organism, like COVID-19 is an organism. It's a very nasty one. It occurs naturally, but also, as we know, has caused a lot of grief to a lot of people. Minerals are also structures, and whether they're solid, like salt, it's a very, very complex structure inside, but they are basically, little cubes, and that's why, salt and even sugar, for that matter, are natural objects. Chemicals as well, whether it's a paste, a liquid, or a solid, those have a structure as well. But there's also abstract structures. For example, data in computers, you can't see it until you display it on the screen, and then you can make some sense of it. You can use it, put it to good use. For those of you who are musicians, you'll know that music has a form, otherwise you'd never be able to read it, or you wouldn't be able to perform it. You'd have to just strictly memorize it, and that would be pretty difficult. Now, when people and animals build structures, there's a few key things that has to be in place. So they need to be strong and stable, and that's because when people and animals build structures, that's where they live. They have to be protected from other animals, from the cold, the wind, floods, and those structures have to last a long time. When animals build structures to survive, I'm sure some of you have heard of the law of the jungle. So they have to protect themselves physically with some type of barrier. In this particular case, this photo here is a beaver dam. So it'd be pretty hard for any type of animal to unpack all those trunks and branches and twigs. So beavers are very, very capable building almost an impenetrable kind of structure with their dams. Now, in the case of people, when they build structures, certainly for sure it's a place to survive, to let them survive, but also a structure also makes a statement. When someone builds a church, for example, they're large buildings. When somebody is quite affluent, has lots of money, they will build a very large house, maybe with multiple garages and a pool and indoor bowling lanes. So in that case, it's more than survival. They also want to make a statement. They want to show everybody that they have a lot of money. Now, if taking it the next step, when either humans or animals make structures, there's four things that are important. One of them is the form. It can't be just loosey-goosey. It has to kind of stay together. It has to perform a specific function. It has to have enough strength so it won't fall down on its own, or if it gets hit by a windstorm. And then stability means that it has to kind of stay up. It has to maintain its form and function for a long, long time. So let's take a look at four examples. So in the case of Roman aqueducts, and I'll show you a photo in a minute, so they used kind of these bridge-like structures to carry water from their source down to where people lived. In the case of Egypt's pyramids, so you'll see them here in the middle photograph, they were tombs for royalty, kings and queens. So it's a very noticeable form. The function, it was a tomb. They're very strong. They're made out of large stones. And they seem to have survived thousands of years, so they're certainly very stable. When you take a look at beaver dams, and let's take a look at this wonderful beaver dam over here, the form looks ragged. It looks kind of crazy, but beavers are very smart animals, and they just know how to build effective dams to kind of hold water back. The function, it's their home. It's very, very strong, unless maybe ice will break it up in the springtime. And beaver dams are known to have survived a long time. So beavers, they just want to do it once, and they do it very well. In the case of beehives, they know where to place them. It's usually on a very strong branch, because beehives can be very heavy, with hundreds and thousands of bees. So the function, it's their home. It's a very strong structure. And you'll notice in terms of the form, it's almost a perfect sphere. So it has the least wind resistance, and beehives can last a long time. So let's take a closer look at Roman aqueducts. So this is a schematic. This is not a real one, but you'll see there's either a lake or a basin where they would collect water. And what the Romans did is they built this big structure. So this is the aqueduct. So it's like a bridge-like structure, and then at the top is what they call the conduit, and that's where the water flowed. And once again, since the Romans were pretty smart, they also designed in what they called an inverted siphon, which meant the water could go down into a gully and come back out at the other side. And this is without pumps, without diesel engines, without anything. And these aqueducts, they've somewhat deteriorated over time, but in terms of the overall structure, it's all still there. You can see them in Europe in many places. Taking a little bit of closer look at the pyramids, obviously the shape is still perfectly as it was originally built. Now over time, some of the stones have kind of corroded or have been basically sandblasted by windstorms in the desert. So this was a large one, and then in many cases there were a couple of smaller pyramids off to the side for the children of the emperors or kings and other royalty around. Now the interesting thing about pyramids is they were always built on the west side of the Nile River, and that's because where the sun sets, symbolically, that's where the people went. So when the sun sets on a person, that means they've moved on, they passed away. But interestingly, the pyramids also needed to be away from the danger of flooding from the Nile River. Nile River is a large river, and in rainy season it would flood, and of course they didn't want their pyramids that took a long time to build, because there was no cranes, there was no backhoes, there was no power equipment, and this was all built with very simple machines, rollers, ropes, and then a lot of people pulling those large blocks around. Now if we take a closer look at a beaver dam, dams hold back streams and interestingly provide a habitat to songbirds. So birds obviously like to eat insects, among berries and other seeds on the ground. So beavers are pretty smart. They take care of themselves, but they also help other wildlife around. And as a number of people have said, beavers are essentially ecosystem engineers. So by building their dams, they help degrade degraded stream habitats. Means if there was too much erosion going on, the beavers will build a dam and the degraded stream habitats come back to life. And they recharge water tables. Obviously, there's a little bit of a pond back here, upstream from the beaver dam, and they create some wetlands. So this pond obviously is quite large. You can't quite see how far back it goes, but it's very useful for, frogs, small fish, maybe crayfish, and other wildlife in the area. And then when we look at bees, bees are very smart. They know how to build hives, and there's hundreds and thousands of bees, so they all work together. In this case, they've attached their hive to a wood fence. Inside the beehive is the honeycomb, and it's a structure made of beeswax. I'm not sure if anybody has seen and felt a honeycomb. It's quite soft, but it's very strong. And the hexagonal shape of each of the cells in a beehive makes for a very strong structure, because even the little cells themselves are a structure within a structure. The cells inside the beehive store food, and it's a safe place for young bees to grow, and then they turn into full adults, and they help create the next beehive wherever that needs to be. And then, of course, as we all know, bees produce honey, and as they go about making honey, they also pollinate nearby crops, which is a very, very important life cycle for not only the bees but also humans that have to grow maybe sunflowers or other plants that require bees to pollinate, because that's the bees are just doing their job. Then we have to look at the forces that act on structures. And the 5 forces, there's basically 5. So the blue one right here is called compression. So that's when something or structure gets pushed down from the top and or the bottom. So you'll see the blue thing here is kind of bulging. The next type of force is something gets pulled on. And when that happens, there's a little bit of a kind of caves in at the center. And a simple way to look at that is you take an elastic band. When you pull it, it kind of gets narrow in the middle because it's trying to hold back, and then all the material goes towards the center. The third type is bending. So when you take a metal ruler or you take a piece of wood, that's another type of force. So there's top and bottom are pushing one way, and at the center it's pushing the other way. The fourth type is called torsion. So basically when you twist something. So when you tighten a screw, drive a bolt, or even if you run a pepper grinder, so you're applying a torsional force to the pepper grinder. And the last one is called shear. That's when two things kind of slide one against the other. So the force on top goes one way, force at the bottom goes the other way. So in the case of water, water typically causes a shear force. And when the soil and the silt and maybe in some cases logs can't withstand the force of the water, then there's a shearing action taking place, and the logs go down the river. They don't just stay there. Air also causes a shear force, but it may also cause bending. Because if, let's say a bridge has a top and bottom, and if some of the suspension members get wind gusts at the center, then those will bend because the whole bridge can't tip over, otherwise it wouldn't be a bridge anymore. And then specifically, you always have to watch gusts. Very rarely is wind perfectly steady, so you have to make sure that you take into consideration how high the gusts will be. Then, of course, there's the ground. Here again, shear is usually the most damaging thing when it comes to forces acting on structure. So if there's a slope, the soil will want to go down. If the soil is very wet, it kind of gets muddy and mushy, and it'll flow. And then earthquakes and avalanches are their classic examples of, in some cases, torsion, but most of the time it's shear with a little bit of compression. And then with structures made by humans, they have to be able to hold up people, they have to hold up vehicles and other objects on them, like people with strollers or vehicles pulling a trailer. So bridges, garages, airport, parking terminals, they have to hold things up for them to serve the purpose that they were built for. And lastly, which is sometimes we forget about it, but if you look at corrosion or oxidization, that means some metal or material, when it acts with moisture or other gases in the air, may cause oxidization, which is otherwise known as rust when it comes to steel. And as we all know, you may have gone through a field and you pick up an old pail, which was like a paint can, and you pick it up. It's been sitting there for years and years. You pick it up from the handle and it falls apart. So that means that can has oxidized, namely rusted, and obviously it doesn't serve its purpose anymore. Lastly, one topic which is becoming more and more important is how engineers model structures. So in this particular schematic here, so this is typically called three-dimensional CAD. So this is a building. The orange kind of pegs down here is the foundation. The dark blue is kind of the mounts. And then inside are the beams. And then there's piping, and then there's flooring, and then there's walls, etc., etc. So engineers nowadays are able to run simulation software to make sure that the building will be strong enough, won't fall over, to make sure the foundation is strong enough to handle whatever will be in this building. It could be a parking garage, it could be a factory. So they have to make sure that everything will be strong enough to support it. Another way engineers model structures is to build a scale model. So when you look at it physically, three-dimensionally, then you can tell whether it's going to work or not. A third way is you conduct inspections. So if you run simulation or build a scale model, you can try putting simulated loads on the building, on the structure, whether it's a bridge, a building, or otherwise, and you see how it behaves. And then, of course, a building has to contain things for it to be useful. So the building has to house piping, which could be air supply, water supply, could be drainage from the roof. If it's a manufacturing environment, it has to handle high pressure liquids, sort of like hydraulic pumps. It has to have space for air ducts, for air distribution, heating in the summer, in the wintertime, cooling in the summer. It has to have room for elevators, which themselves have to have their own special structure. And then, of course, as much as possible, buildings have to receive as much natural light as possible, so you don't have to spend as much money, providing lighting internally. Hope this has been helpful, and congratulations to all of you for continuing to learn a little bit under difficult circumstances, and I'm sure all your hard work is paying off. Thank you, and good luck.